Good morning to one and all present here. Myself, G. Rajpriya, working as a assistant professor in Erode Engineering College in the Department of Electrical and Electronics Engineering. So today I am going to discuss about the topic on construction details of DC machines. So, a DC machine is an electromechanical energy conversion device. It means it can convert the mechanical power into electrical power or electrical power into mechanical power. So, the conversion of mechanical power into electrical power can be achieved by with the help of DC generator. The conversion of electrical power into mechanical power can be achieved by with the help of DC motor. So the working principle of DC generator. So the energy conversion is based on the principle of electromagnetic induction. According to the Faraday's law of electromagnetic induction, whenever conductor placed in a magnetic field, dynamically EMF is induced in the conductor. So, when the armature is rotating in the magnetic field, an EMF will be induced in the armature conductors. So, the direction of induced EMF can be found by Fleming right hand rule. So, the construction detail is common for DC generator and DC motor. The direction of induced EMF is different for motor as well as generator. So for motor it is a Fleming left hand rule. For DC generator, Fleming right hand rule. So this is the cross sectional view of DC machine. It has the following parts like yoke, field winding, armature core, armature conductors, brush, main field winding, armature winding. So these are the main constructional features of the DC machines. So first one, magnetic frame or yoke, and second one, pole core and pole source, and third one, field winding and exciting coil, fourth one, armature core, and fifth one, armature winding, and sixth one, commutator, and seventh one, brushes, and eighth one, bearings, and the last one, shaft. So this is the cross sectional view. So first we are going to discuss about the magnetic frame or yoke. So the outer frame of the DC machine is known as yoke or magnetic frame. It used for two purposes. The first one is it acts as a protecting cover for the whole machine and provide the mechanical support to the poles. And second purpose is it carries the magnetic flux produced by the poles. The flux per pole is divides as the yoke, so that the yoke carries only half of the flux produced by the each poles. And basically it provides a low reluctance path for the magnetic flux. So the yoke is made up of cast iron material for smaller machine, but for larger machine it is made up of cast steel or rolled steel material be preferred. Since the permeability of steel is double than the cast iron, the area of cross section of yoke hence the weight has reduced by half. So next one, pole core or pole source. The pole is consist of pole core, pole source and pole coils. The pole core and pole source is a form of the field magnet. The end of the pole core towards the armature is often expanded in the form of so to reduce the reluctance of the air gap since the cross section becomes the larger at the bottom. Since the poles are electromagnets of a field winding are wound over the pole core. The pole coils are made up of copper wire. When the current is passed through these coils, the pole becomes an electromagnet and starts to establishing a magnetic field in the machine. So, the pole core is a part of magnetic circuit and pole shoe is a extended part of pole core. It has larger high section, so the reluctance of the magnetic path is reduced. So next one, field coil or exciting coil. So the field coil or exciting coil are used to magnetize the pole core. So it is made up of enarmed copper wire used for the construction. When the direct current is passed through the coil, it sets up the magnetic field which magnetizes the pole core to the required flux. So next one, armature core. So the armature is mostly consists of two main parts, and that is first one armature core and second one armature windings. So the armature core houses the armature conductors or coils. The armature along with the conductors rotates under the poles and the flux is produced by the field magnet is cut by the armature conductor. So the armature is a rotating part of DC machine and reversal of flux takes place. So the hysteresis losses is produced. To minimize the losses, silicon steel is used for the construction. When the conductors rotate, they alternatively come under the influence of north and south poles. This causes high hysteresis losses in the armature core. To reduce the losses, low hysteresis steel containing a few percentage of silicon is used in the armature conductor. So the rotating armature cut the magnetic field. Therefore, an EMF is induced in the armature core. This EMF circulates the eddy currents in the core, which results in eddy current loss in it. The armature core used for the following purpose. It houses the conductors in slots. It provides an easy path for the magnetic flux. The next one is armature winding. The number of conductors in the form of coils placed in the slats of armature and suitably interconnected are called winding. Armature winding. The armature winding is conversion of power takes place, that is in case of generator mechanical power into electrical power. So the purpose of armature conductor is to cut the magnetic flux and EMF is induced. So the armature conductors are usually made up of copper and are housed in the slots provided in the armature. The slots are in rectangular shape for large machine and circular shape for small machine. The conductors are housed in the slots in two layers. So the slots are enclosed by the fiber or wooden wedges to prevent the conductors from flying out due to the centrifugal forces. So next one is commutator. The commutator is the converts the alternating EMF into unidirectional or direct EMF. So it is made up of wedge-shaped segments and insulated from the thin layer of mica. So the segments are held together by clamping flanges that pull the segments inward. The flanges are down together by bolts and cap screws. The flanks are furtherly insulated from the segments by two rings of mica. So the purpose of commutator is it converts alternating current induced in the armature conductors into unidirectional EMF. That means it acts as a rectifier. And next one is brushes. So the brushes are made up of carbon or graphite material. So the function of brush is to collect the current from the commutator and to convert it to the external load resistance. Mostly it is preferred in rectangular shaped material. So the brushes are housed in with brush holders and mounted over brush holder sets. The brushes are held in particular positions around the commutator by brush holders. So the brush holders sets are insulated from the brush yoke by the insulation sleeves. So next one, bearings. The function of bearing is used to reduce the friction between the rotating and stationary parts of the machines. Those are fitted into the end housing. Generally, high carbon steel is used for the construction of bearings. So for ball bearings are preferred for the light machines. For heavy machines, duty machines, roller bearings we preferred. So next one, shaft. The function of shaft is used to transfer the mechanical power to the machine or from the machine. The shaft is made up of mild steel with a braking strength. All the rotating parts like armature core, commutator, cooling fan can key to the shaft. So basically DC generator classified into two types, that is self-excited generator and separately excited generator. The self and separately excited generator classification is depends upon the excitation of field winding. So we already discussed DC generator or DC motor consists of two main winding, that is field winding and another one is armature winding. So the field winding is energized by external DC supply. That means with help of battery we will energize the DC. We will energize the field winding means it is a separately excited DC generator, and otherwise The field winding is energized by with the help of residual magnetism means it called as a self-excited generator. Okay, that means the excitation of field winding. Okay? Depending upon the excitation of field winding, classified into two types. That means self-excited and separately excited. So the self-excited DC generator again classified into three types. So first one sun type, series type and common type. So depending upon the field winding and armature winding connections, it classified as a three types: sun, series and compound. So sun mean the armature winding and field winding. Both windings are connected in a parallel manner is known as DC sun generator. The armature winding and field winding, both windings are connected in a series manner is known as series generator. And third one, compound generator. So basically the compound generator has three windings, and that is one is series field winding and sun field winding and armature winding. So depending upon the connection of series field winding and sun field winding, it again classified into two types. That means long sun and short sun. So long suns mean the sun field winding is connected across the both series field winding and armature winding is known as long shunt. For short shunt common generator mean the sun field winding is connected in parallel with the armature and the combination is connected in series with the series field winding. So the long shunt and short shunt again classified into two types. That means differential and cumulative. So differential means the armature flux and field flux both are in opposite direction means differential common generator, and sun field flux and the armature field flux are in the same direction means cumulative generator. So this is the main constructional features and working principle and types of DC generator. So we already discussed the DC generator is based on electromagnetic induction principle. The induced EMF is Fleming right hand rule, correct? So Fleming right hand rule means the thumb always indicate the direction of conductor motion and first finger indicates the direction of induced EMF and second finger indicates the direction of magnetic flux. So this is the Fleming right hand rule. And next one, application of DC generator. So basically DC sun generator is used as a battery charging, incandescent lamp working, this one, and this is the main construction and working principle of DC machines and type of DC generator. And thank you.